So you have a film camera with a non-working light meter. So what can you do to determine proper exposure? In this edition of Jules Voto's Photo Focus, I'm going to give you the best solution to this problem. A lot of photographers, myself included, have cameras with non-working light meters, such as this excellent Canon FTBN. Great camera, meter doesn't work. So is it just a paperweight? No. You can use it if you can determine proper exposure. Also, some of us have cameras such as this Pentax H1A, which dates from the early 60s, or this Nikon F with plain prism finder. They don't have built-in meters. Now also, some cameras may have a working meter. However, you can't get the proper battery for it. A lot of those cameras, the FTB included, required a 1.35 volt mercury battery. Those batteries are no longer made. There are substitutes. However, some of those substitutes have a very short life, or you can use a different voltage, but you need modification to the camera. So what is the best solution? Well, you could use what's called the Sunny 16 rule. Doesn't require any equipment. Let's say you have an ISO film of 400 in your camera, and you're photographing in full sun. Your subject is in full sun. You set your aperture to f16. That's where we get the description, Sunny 16. And you set your shutter speed to the closest speed to the film speed. So in our case here with a 400 speed film, we set our shutter to 1/500th of a second and our aperture to f16, and we get well exposed images. But what happens if the sun isn't out, or you're in shade, or it's just dark all over, or you're photographing indoors? You can guess your exposure, but of course the best way is to be able to measure the quantity of light. And in that case, a handheld meter comes in to solve our problem. Now, there are two types of meters. One measures reflected light, like the meter in your camera with a working meter does. It measures the light reflected from the subject. The other is an incident light meter. That meter measures the light falling on the subject. Now, there are also different types of light-sensitive cells in light meters. Now, the oldest light meters use selenium cells. They do not require a battery. I'm holding here an old selenium meter, a Gaussian Pilot from, I guess, the early 60s. And these meters convert light into energy, which causes a needle to move, and then you match a pointer on the meter with that needle after setting your ISO into the meter, and it gives you a combination of shutter speed and aperture to set on your camera. The nice thing with these meters is they don't require the battery. However, they're not that great in low light situations. Now, in the early 1960s, a new type of meter was introduced. It used CDS cells, and they were used in most of, I should say, the early cameras that had built-in light meters, and they did require a battery. They were more sensitive to light than a selenium meter. They also worked well in low light. One issue with the CDS cell, it had what they call memory. If you were out on a bright day, you took a reading, then you went indoors, your reading would usually be off because the meter still thought it was bright. It remembered that bright light. So you had to wait a few minutes. Not a big deal. Now this is a Gossen Luna 6. It dates from the mid-1960s. At that time it was considered one of the most sensitive meters. This one actually works. It uses two 1.35 volt batteries, but I was able to get an adapter, which is actually for a Nikon Photomic FTN, and it takes now two silver batteries. I just have to do a modification to the ISO I set to get an accurate reading. Okay, so what happens next? Now, in the early 70s, a new type of meter cell was introduced, silicon blue cells, sometimes referred to as SBC cells. They are still used to this day in light meters. They do not have that memory effect. They react quicker to the light than a CDS cell. Very accurate readings you get with one of those meters. Handheld meters have a different angle of acceptance, a different angle of view that they measure. For example, this Gossen Luna 6 has an angle of acceptance of about 30 degrees, okay? This more modern meter that I have here, this is a Sekonic L308. This has an angle of acceptance of 40 degrees, so it gives a wider view. It takes in a wider view. And as I said earlier, meters either are reflected or incident. Well, this meter, by just sliding this hemisphere over, will give you an incident reading, the light falling on the subject. Same thing with the Gossen. This also has one of those little milky white hemispheres. You just slide it over and you can measure incident light. And I'm going to show you how to use a meter in a minute and then explain how to interpret those readings. Okay? Also, I should say, this little pilot also, by sliding a little dial here, will give you an incident reading. Okay, now some meters have either as an accessory or built in a viewfinder, so you could see exactly what the meter is measuring. Some of those meters are 1 degree spot meters. They will measure just a very small portion of the scene. Very accurate to get good exposures. However, they require some knowledge and you have to be careful when using them. You don't want to measure, let's say, the sky when you're trying to shoot a group of trees. Okay, so excellent meters, very accurate, but also very expensive. There were many 1 degree spot meters back in the 60s and 70s. Some were made by Honeywell, Minolta, and others. And currently, there still are a few. Sekonic makes one. It's the Speedmaster L58D. It sells for $700. It is a 1 degree spot meter, but it's also an incident meter and also a flash meter. And I will explain in a little bit also and do a demonstration of how a flash meter works. Now, there are also many light meter apps for your phone. Some of them are free, some require a small charge. I have one called My Light Meter Pro. Small charge for that. It will measure both incident and reflect and light. Nice thing is it uses the camera on your phone to actually show you what it is measuring, and it is pretty accurate. So if you don't want to spend money on a handheld meter, you have them right here in your smartphone. Okay, so now I'm going to show you how to use a handheld meter. And the meter I'm going to use for this demonstration is my Sekonic L308X, which, as I said, is both reflected, it's incident, and it will do flash metering. So what I'm going to use for this demonstration is my favorite model here. It's my mannequin head. And what's great about her is she doesn't move, she never gets tired. As I was editing this video, I realized that I didn't show you close-ups of the meters and how they work. Now, so before we continue,
with the metering of the mannequin head. So I set up the camera on a tripod, shooting the video, an LED light, some seamless paper, and my Mamiya C220. And I just want to go through each meter real quick and explain better how they work. All right, so this is a selenium meter. Selenium meter, as I said, does not require a battery. Once you open it, open up the case, okay, it starts to measure light. And you will see down here a little needle. I hope you can see that right here. And let me just cover. You can see how the needle moves to the left, all right? In brighter light, it moves to the right. I have set an ASA here, or ISO, of 400. And again, I hope I'm not blocking this and you can see this. You just turn this dial here and it's set for 400. Okay, I'm now going to aim it towards the camera and turn the dial, which has this little pointer on it, to line up with the needle. Okay, so it gives me a reading of 1/125th of a second at f4, or 5.6 at a 60th. All right, same thing with the CDS meter, the Luna 6. I set the, basically the same type of dial. I set the ASA, or ISO, as we now say today, just by turning it. Now, I am setting this at 200. As I stated, this meter takes 1.35 volt batteries. They're no longer made. I used an adapter to take two 1.5 volt silver batteries, but that throws the reading off, so I just have to set it to 200 if I'm shooting 400 speed film. So with this meter, since it has a battery, you need to activate it. Okay, so I just press the button on the side, press it down for bright light, press the top portion of it. It's kind of like a rocker switch. For dim light, and here, since the light is so bright, okay, and that's indicating the needle here. When I was aiming it towards the camera, it indicated 14. So then I just turn this dial, okay, and on the scale here, I turn it to 14, and it gives us a series of readings, a series of exposures. For example, a 30th of a second at 5.6. All right, so that's how the Luna 6 works. The Luna 6 also can read incident light by just moving the dome over to the center. Okay, so here it's set for reflected light. That's where it's reading from there and over to incident light. And if you're using this as a reflected light meter reading, normally you would be at camera position aiming it at your subject, or move in close for a close-up reading. If you are using it for incident light, you have the dome in place and you aim it towards the camera, towards the light source to get your reading. So now the Sekonic. You need to set your ISO. So I'm just going to hold this button in up top. The meter turns on. Okay, there's a mode selector button here. Okay, for flash, but we're going to use it for for continuous light. Okay, I then set my ISO. Now I already have it set to 400, but there's an ISO button here near my thumb. I'm going to hold that in, and then there are two buttons here. One has a down arrow, one has an up arrow. If I want to go to a lower ISO, I just hit the lower button. You can see the number changing. Right now it's at 250, but I want to have it set to 400. Okay, so I'm now at 400. Okay. I then aim it at the subject from camera position, normally, as I said, and hold in this button here. And it takes a reading. Obviously, I'm taking a close-up reading here, and it's indicating an exposure of 1 1/25 of a second at 4.5. If I want to change my shutter speed and see what other combinations are available, I just press the down arrow. So at a 60th of a second, it would be 6.3. And let's go back up here, pressing the upper arrow. At a 2/50th of a second, it would require exposure of 3.2. If I wanted to do an incident reading, I just slide this over, aim it at the light, hold in the button, and it gives me a reading of the 2/50th of a second at 2.0. Again, I could simply change different shutter speeds and it shows me the appropriate aperture. Okay, so it's very simple to use. It also can meter flash. Okay, so now let's get back to the model, and now you know better how the meter works. So now I'm going to show you how to use a light meter. All right, I got to duck down a little bit. I'm doing this in my family room, and it's a little tight in here. So, all right, I have my Sekonic L308, and the reason I'm ducking down, you would lose the top of my head. I would, no great loss, but I think this will work out a little better if you could actually see what I'm doing, of course. So the first thing you need to do, of course, is turn the meter on. Nice thing with this Sekonic, it just takes one AA battery. I believe a similar model to this is still made. I think it sells for around $260. So I have it set for reflected mode, but first thing you do after turning it on is set in your ISO. Okay, so I have it set here for an ISO of 400, and I have it set to read reflected light. The way you use a reflected light meter is you point it at the subject, and you can do that from camera position, right? Just aim it at your subject. However, this has an angle of acceptance of 40 degrees. So I took these pictures a little earlier of this scene. So you can see all the light coming through, okay? And if I use that reading, this is what the image would look like, okay? The subject is basically invisible, because the meter is being fooled by all the light from those windows. Similar situation could be you're at the beach photographing your kids and their back is to the ocean and you got all that light from the sky, the sun, the water, and you would get a similar picture. The kids would look like silhouettes. So what you do in a case like that, you come in close and you meter off the face. Now you got to be careful, so I'm just going to aim the meter at the model's face, and that gives me a different reading. Okay? It requires more exposure, a wider aperture, or a slower shutter speed to properly record the subject, and this is the resulting image. You could see it's a lot better. So to do that, of course, you have to be able to walk up close to your subject. Can't always do that, okay? So from camera position, let's say you're doing a landscape, and there's a good deal of sky in the image, well, just tilt your meter down. Okay, you can't walk up to a distant mountain, but that's where, of course, a spot meter would come in handy. But you just aim your meter down a little bit so you're not picking up too much sky. But the other option, you could take an incident reading. So in a case like this, right here, I could take an incident reading. And when I did that earlier, these are the results. Okay, you could see the exposure is the same as it was with the reflected light meter reading off the subject itself without getting in all those bright windows. So that's what's nice about having the availability of both an incident and reflected meter in one. A built-in camera meter, of course, you can't take an incident reading. You can only take a reflected light reading. However, today's camera meters on digital cameras have
the availability of several different types of built-in meters, including a spot meter. And in a case like this, if you have all this bright light coming in again, I shot those images you just looked at a little earlier. The blinds were open. There was a lot more light coming in, and a spot meter reading would have been the way to go. All right, now, we know how to use the meter now, right? We know how to measure reflected light. We know how to measure incident light. But there's more to it. And I'm going to go back to my chair and explain to you how to interpret these readings and how to get the best possible exposure. Okay, so now we did our reading, we set it into the camera, and most of the time, we're going to get a good image, a good representation of our subject. Okay? But in some cases, we're not. As I said, a lot of light coming from behind, the meter sees that light, our subject is going to be underexposed. Meters are set to basically turn everything into 18% gray, a medium gray, like this gray card here. Okay? So to demonstrate this, of what would happen if we took a meter reading of a black object, let's say. Let's say we were photographing a horse, a black horse. To illustrate that, what I did, I photographed this black card. Okay, it has a hole in it because I used it for another purpose at another time, and you will see that hole in these images. So what I did, I took a reflected light reading off of that black card. It was set up right in front of the mannequin. And the reading I got at ISO of 400, and that is just with the room light, the window light coming through from behind. I didn't have the LED light that's on me now. And I got a reading of 1/4 of a second at 3.2. And here is the resulting image. Doesn't look black, does it? Looks gray. So what I did, I closed down a stop. I went from 1/4 of a second to 1/8 of a second. And it got darker, a dark gray, I guess you could say. And then finally, I went to 1/15 of a second. So that is 2 stops down from the original reading, and it looks black. So you can see what the meter is doing. So you must interpret your readings if you're photographing a subject that's darker or lighter than a medium gray. All right. So what I then did, I photographed the other side of this card, the white side. Okay, same, did not change anything, did not change lighting conditions, but I took a meter reading off of the white card, and it gave me a reading of 1/4 of a second at f8. Okay, whereas when I metered off the black card, it gave me a reading of 1/4 of a second at 3.2. The resulting image at 1/4 of a second at f8 of the white card, the card looks gray because that is what the meter is programmed to do, to give you an 18%, a medium gray. So I opened up a stop. I went from 1/4 of a second at f8 to 5.6. Now it looks like a lighter gray, right? Then I opened up another stop. I went to 1/4 of a second at f4, and now we have a white card with a little bit of texture in it. And I opened up one more stop, 1/4 of a second at 2.8, okay? So that is 3 stops open from the original meter reading, and it gave me pure white. And then just for the hell of it, I took an incident reading. Now, an incident reading is not being influenced by the color of the card. or the white snow, or the sunlight behind the subject. And it gave me a reading of 1/4 of a second at f4, which was the reflected reading opened up 2 stops. So an incident reading sometimes is your best bet because it's not fooled by the reflectivity of the subject. Now, what I just explained here is the basis for the zone system. I know some of you have heard of Ansel Adams. He invented the zone system. It was further refined. I believe it was Minor White. Ansel produced some books back in the late 40s, early 50s. I don't believe they are, in fact, I know they're no longer in production, but you can find them. But I recommend this book. It's kind of a little more simplified. Ansel goes into great detail, and I recommend this book. And it's no longer in print. It's The Zone 6 Workshop by Fred Picker. This book dates from the 80s. I have seen it on Amazon used. I highly recommend it. And basically, he gives a really good explanation of Ansel's zone system. He also has an example in there. He didn't use a white card, he actually used a horse. So he has photographs of a black horse and then a white horse, basically the way I did this. And just real quick, the zone system breaks down reflectivity of subjects into 10 zones. 0 being complete black, up to 9, which is pure white with no texture. And in between, zone 5 is that 18% gray. Now, the zone system was primarily designed for black and white photography. It is far more sophisticated than what I just told you. Ansel recommends the use of filters in certain situations, of increasing development in some, reducing development in others. And when he developed this system, of course, he was shooting sheet film. Okay, so I'm going to break this down and go back and show you one more thing. I'm going to show you how to use a flash meter. And a flash meter would be used if you have studio lights set up and you want to get an accurate reading to set into your camera. Okay, now I'm going to show you how to take a flash meter reading. Okay, you're going to set it for incident, and you're going to set the mode on your meter to flash. Now, there are some dedicated flash meters, at least there used to be. I'm not even sure if there are anymore. It's just better to buy a meter that will do reflected, incident, and flash. So I have set up a single monolight with an umbrella, and plugged into it, I have a Pocket Wizard radio slave. I have another one in my hand. What you will normally do is, after you take your reading, you could have another one of these set up on your camera, one of these Pocket Wizards, so it will fire the camera without any cable, or you could use a cable. But the basic thing we want to do here is just want to show you how to use it. So, and one other thing before we continue with this, I don't know if I clearly indicated, when you take an incident reading, whether it's a flash meter incident reading or a continuous light reading like I demonstrated earlier, you really, in most cases, don't have to make any modifications to your exposure. Okay, you just basically go with the incident reading. Sometimes if a subject is a little more on the dark side, you may have to open up a little bit, usually no more than 1/3 or 1/2 a stop. Same thing with something real bright. You may have to close down just a little bit. But basically, you're good, especially with negative film, to just go with the incident reading. Okay, so what I'm going to do right now is press the button on the meter so it can take a reading, and I'm going to press the button on my Pocket Wizard. It's going to fire the flash, and it gives me an aperture. In this case, it's 5.6. I set 5.6 into my camera, and I get a perfectly exposed flash picture. Okay, so I know I presented a lot of information here, but a handheld meter really comes in handy. I mean, it's even good if you have a digital camera with all those great built-in meters, the spot, the averaging or evaluative, whatever you want to call it, center-weighted metering and so forth. Modern digital cameras have all that built in, but sometimes it's better, as we have seen, to maybe just take an incident reading, or if you're in a studio situation, to use a flash meter. And meters like the Sekonic can do it all. Okay, so if you have any questions or comments on this video, please leave them in the comments below. I always try to respond to all questions and comments. And if you enjoyed this video, please give it a thumbs up and subscribe to my channel. I publish a new video every Wednesday morning at 11 a.m. Eastern Time. So I will talk to you soon.